Good morning to all. Welcome back to our course on the C programming language. In today's session, we will discuss about the concept on arrays in the C programming language. In the previous session, we have seen some of the introductory concepts related to C, related to arrays in C. And in today's session, we will be discussing about the definition of array, and then we will see some of the properties of arrays. And the last topic which we are going to discuss in today's session is the declaration of arrays. And within this declaration of arrays, we will also see the memory representation of arrays. That means how the elements are going to be stored inside these memory when we declare array. This is what we are going to discuss under this memory representation. So in the previous session regarding the introductory concepts to arrays, we have seen what an array is. The definition of array says that it is collection of elements of similar data type. So it is nothing but collection of elements of similar data type, and they are stored in the contiguous memory locations. They are stored in contiguous memory locations. What does this mean? Means if we consider the array, we are going to make a set of elements that belong to the same data type. For example, if you take or if you want to store 10 integer values, instead of taking 10 different integer variables, we will make everything as a single entity, right? That means we are going to store all these 10 elements under the single name that we call them as array. And one important thing that we should understand here is they are stored in the contiguous memory location. So whatever number of elements you declare, whether it is 10, 20, 30, whatever it may be, everything is going to be stored in the contiguous memory locations. This is the definition. And coming to the second part, that is the properties of arrays. The definition itself gives a lot of properties. It says that all the elements belong to similar data type. So that is one property. So all elements are of same data type. This is one of the property of the arrays in C. And the second point also, it comes from the definition of arrays. It is nothing but every element or all elements in the array occupies the contiguous memory locations. And one more property regarding this arrays is it facilitates the programmer to randomly access the elements. Randomly access elements is possible with these arrays. These are all the three properties which comes directly from the definition. And one important point you should understand it, that the arrays allow the access of elements randomly also. You can access them in the sequential fashion, starting from the first location to the end location, or you can access any element in the array randomly. And after these properties of arrays, let us go with the discussion of the third part, that is the declaration part. Declaration of arrays. As we know that to learn the programming languages, we should have good a sound knowledge on the syntax part. This is syntax is nothing but the rule which is used to define something in a programming language. So a syntax is nothing but a rule. While you declare an array, there exists a syntax, and the generalized syntax for declaring an array is it should start with a data type, like the fundamental data types like int, char, float, double, anything you can make use of it, data type. And after that you leave some space, a white space, followed by an array name. And this is important. Array name is nothing but an identifier. And after you give the name of the array, you should open a square bracket. Square is mandatory. And inside that square bracket, you should specify the size of the array. This is the generalized syntax. As I told that the data type can be any fundamental data type, or it can be a user defined data type also, like the structures and unions. We know very well about these fundamental data types. Some of the examples related to fundamental data types are int, float, char, double, etc. So you can make use of any of these fundamental data types, or as I told that you can make use of any user defined data type also. And this array name is nothing but the identifier. An identifier is a name that is given to any construct in the C programming language, and we have seen some of the rules that you need to follow when we are naming these identifiers, or when we are making use of these identifiers. Like it should start with only alphabets. You should not start with an integer. An identifier may consist of both alphabets and integers. Alphabets in the sense you can make use of both uppercase letters as well as the lowercase letters also. And no special characters are allowed except underscore. The identifier can start with an underscore. Like that we have so many rules which we have discussed in the previous sessions. All the rules what we have discussed there will be applied to the identifiers or the name of the array also. And this size is nothing but an integer value. You cannot make use of a floating point value. You cannot make use of a character. It is always an integer. You should specify the size as 10, 20, 15, 11, 12, depending upon your application and depending upon your need. You can specify the size of the array. You cannot specify the size as 13.5. That means the float values for the size is never accepted. Let us take an example. I want to declare an integer array of size 10. So for this I need to make use of, since I want to declare an integer array, I need to make use of the integer keyword. So the data type I have used is integer. After that I leave a space, a white space, and then I should give the name of the array. Let me say that I give the name of the array as uppercase A. This is also an identifier, highly accepted, nothing wrong in it. After I specify the name of the array, I should specify the size of the array within the square brackets. Let me assume that I give the size as 10. What does this mean? This is a declaration statement. And when the compiler sees this declaration statement, it will come to know that the user or the programmer is trying to declare an array called A, and it is having 10 elements, and all these 10 elements are of type integer. In simple form we can say that the compiler will come to know that the programmer is trying to make use of an array that consists of 10 integer elements. That means we are going to store 10 integer elements in the contiguous memory locations. Coming to the size of this array, the size of the array we have specified it as 10. And what is the total memory occupied by this array? This is also very important. We know that in C programming language the integer data type occupies 4 bytes. So one integer occupies 4 bytes. Here I am going to make use of 10 integer values, or I am going to store 10 integer values. I am going to deal with 10 integers. So 10 integers is equal to occupies how many bytes? It is equal to 10 multiplied with 4 bytes for each integer. Total memory occupied by this entire array is 40 bytes. One thing you should understand here is you may make use of all these 10 elements, or you may use only 2 elements, or you may use only 5 elements. This is the primary disadvantage of the arrays. Arrays makes use of the concept called as the static memory allocation. Static memory allocation. The main disadvantage of the static memory allocation is you need to have an idea of how much memory you require. You need to have an idea of how many elements you want to deal with in your program. While declaration itself, you have to tell the compiler that I need this much of memory. I want to store these many elements, so I require this much of memory. Based upon your requirement, the compiler will allocate the memory, and that memory will be fixed. You cannot change it dynamically. So when you fix the memory allocation, what happens is there might be a situation where you may not use all these 10 elements. You may use only 2 elements or 3 elements. Let us say I have used only 5 elements. So out of all these 40 bytes, I have used 5 into 4, that is 20 bytes. The remaining 20 bytes will be wasted. This is the primary disadvantage of arrays, and that disadvantage comes from the concept of static memory allocation that we use for the arrays concept. So this is all about the declaration part of the array. We have seen the declaration, we have seen an example, and we have seen what is the total memory occupied by these arrays. And the last part, what we are going to discuss here is the memory representation of the array. This is very important. So in the memory representation, let us take the same example but with less size. I want to deal with an integer array that consists of 5 elements. So this is how I need to declare, right? So int specifies the data type, a specifies the name of the array, and 5 specifies the size of the array. So I am going to deal with 5 elements, integer elements. How these 5 elements are allocated by the compiler? I told that this is a declaration statement, and when the compiler looks at this particular statement, it will allocate the memory. And when the compiler looks at this statement, it will go and search the entire memory, and it will find a place which is having 20 bytes of contiguous memory locations. Why this 20 bytes means? We have seen that to store 5 integer elements, we require 5 multiplied with 4, that is equal to 20 bytes is required. So wherever 20 bytes of memory is available in the contiguous manner, then that memory will be allocated. So let me represent this as the cells like this. Here the first element is this one. This is the first element, and this is the second element, this is the third element, this is the fourth element, and this is the fifth element. This is how the memory is going to be allocated for these arrays. And we know that the name of this entire 20 bytes, this entire thing is 20 bytes. The entire 20 bytes can be called with a common name called A, which is nothing but the name of the array. And here you should know one important concept regarding these arrays is indices concept, index. The concept of arrays makes use of index for the arrays. And remember that the index numbers always starts with 0 and ends with n minus 1, where n is the size of the array. So in this particular example, this one, int a of 5, the size is 5. So the index number starts with 0 and ends with size minus 1, which is equal to 5 minus 1, which is equal to 4. So this is the range of indices that is generated by the compiler automatically for every array. Whatever array you take, whether it is an integer array or character array or floating point array, double array, every array will have the concept of indexing, and this indexing is automatically done by the compiler. The programmer doesn't have to worry about the indexing concept. The only thing that the programmer has to know is the array indexing is always done by the compiler, and it always starts with 0 and ends with size minus 1. This is what the programmer needs to know about the indexing concept. The first location, here you can see that this first box is not a single bit or byte. This represents 4 bytes. That is the first element. And the second box, this one, it is also equivalent to 4 bytes. And the third byte, this one is equal to 4. This is 4. This is 4. So 4 into 5, that is equal to 20 bytes. So make it a habit that you always view these arrays as boxes, and every box represents the size of that particular array element. Here I have declared an integer array, therefore each and every individual box represents 4 bytes. If I declare a character array, then each and every box represents only 1 byte. This is what we should know. And coming back to our indexing concept, we know that the array index always starts with 0, therefore let us assume that the first index is 0. Therefore the first box is having an index of 0. The second box is having an index of 1. The third box is having an index of 2, 3 and 4. So the final box or the final element is having an index of size minus 1, which is equal to 4. This is the concept of indexing in arrays. And you may get a doubt that why we require this indexing concept. The third property what we have discussed under these arrays is random access of elements. So this random access of elements is only possible with the help of indexing. For example, let me say how we can access this particular location or this element. First element is we have to make use of the array name followed by the index number. So a of 0 represents the first element. This is how you are going to access the elements in the arrays. Similarly, if I want to access the second element, it is a of 1. This is going to access the second element. If I want to access the third element, you should access it as a of 2, like this, and so on. So the last element is a of 4, therefore you are going to access the fifth element here. if I want to directly access the fourth element, I know how to access it, right? I can make use of the array name A, and within the square brackets you have to specify the element minus 1. For example, I want to access the fifth element. Element minus 1 means 5 minus 1, it is 4. So A of 4, we can read like this: A of 4 is going to access the fifth element. So the indexing concept is very much useful in the arrays when you want to randomly access the array elements. This is all about the definition part, the properties and the declaration of arrays. Let us have a quick recap of what we have discussed in today's session. We have started our discussion with the definition of array. The definition of array is a collection of elements of similar data types that are stored in contiguous memory locations. And while we represent this memory representation, we need to discuss about these contiguous memory locations, right? You can see here that every element is stored one after the other. This is what is called as sequential memory allocation or contiguous memory allocation, or we can also say that it is continuous memory allocation. These are the indices. Let us say how the memory addresses are being given for these arrays. Let us say that the base address is 100 here. Base address is nothing but the starting address. We give a special name to the starting address of the array, which is called as the base address. In this example, I am taking the base address as 100. And every box, we know that every box occupies 4 bytes of memory. So the last byte that is being used here will be 103, and the starting address of the next element, that is the second element of the array, will be 104th byte, and the last address will be 107. Similarly, for the third element, the starting address will be 108 and it will be 111 for the last address. And similarly for the fourth one, the starting address will be 112 and the last address will be 115. And for the last element, that is the fifth element, the starting address will be 116 and the last address of the last byte element will be 119. So you can see that all the elements of this array that consists of 5 elements, integer elements, everything is stored one after the other. So the first element is stored at 100, the second element is stored at 104, the third element is stored at 108, fourth element at 112 and fifth element at 116. This is the meaning of contiguous memory locations. So we have seen the definition and we have seen the properties of the arrays, which is nothing but which is derived from the definition of the array itself. So all the elements are of same data type, they occupy the contiguous memory locations, and we can access the elements randomly in the array. This is what the properties of array says. And we have seen the declaration part of the array, the generalized syntax, which is the data type followed by array name followed by the size that is mentioned inside the square brackets. And while we declare these arrays, mentioning the size is mandatory. You should not neglect or you should not avoid the specification of size. Why? Because this is the declaration statement, and when the compiler comes across this statement, the compiler will allocate sufficient memory for this particular array based upon the number of elements what we have declared. For example, if you forget to give the size of the array, what happens means the compiler will get confused. How much memory the programmer required? How much memory he wants? This is the question mark the compiler will get. Therefore, it will lead to an error. Therefore, the specifying the size of the array is mandatory while you are declaring the arrays. Very important concept, very important. And this data type can be any fundamental data type, or it can be the user defined data type. Fundamental data types in the sense we have int, float, char, double, etc. And user defined data types in the sense we have structures, unions, enums, etc. Right. So, and we have seen how much memory is totally occupied by each and every array. It is nothing but the size of the array. So this 10 is nothing but the size of the array multiplied with the individual size of elements or individual element size. For example, if you take int char of 50, so the total memory that is occupied by this array, ch, let me take the name as ch, by this entire array ch is size, that is 50 multiplied with the individual element size, which is nothing but 1 byte per character, which is, for this occupies 50 bytes. So the generalized formula is total memory occupied by the array is equal to the size of the array multiplied with the size of individual elements. After this, we have seen the memory representation, how this memory is being allocated for the arrays and how it is going to allocate the contiguous memory locations, what is the base address, what is the indexing concept, very very important concept, indexing. The index always starts with 0 and ends with size -1, and it is taken care automatically by the compiler. The programmer doesn't have to worry about it, everything will be taken care by the compiler. And the indexing is used for random access of elements. And finally, we have ended up our discussion with the contiguous memory allocations that is done by the compiler in case of the arrays with this base address example. That's all for today's session. Thank you one and all for joining the session.